All right, let's do these then. What do you think the shear at this connection will be? Well, the shear should balance the total force. All right, and what's the total force? W naught L. So we'll have a shear of W naught L. And what about the moment? I didn't give myself much room to draw the moment, but I'll draw it there. It'll be that force, but acting through the centroid, which is L over 2, and you'll get W naught L squared over 2 for the bending moment. I'm sure if I gave you enough time, you could get those. Okay, so with that said, what's the shear starting here at the left edge? Positive or negative? It's positive and has a value of, I wrote these are kind of tricky. This one goes there. All right, so that's W naught over L. What's the shear at the free end? 0. So again, we know the change in shear is equal to the area under the load curve. What is the area under our load curve? W naught L. Is that a positive load or a negative load? It's a negative load. So that means if we start at W naught L and I subtract the change, which is negative W naught L, I get 0. So that's working. Now what should be the slope of the shear diagram? Well, it's equal to the load. What is the value of the load everywhere in this region? Constant W naught, and it's positive or negative? Negative. So that means we have a constant negative slope. In fact, if I ask you to identify it, it would be negative W naught. So there's your shear diagram. Also notice we talked about before, due to this integral relationship, if your load is constant, your shear is going to be linear. If your shear is linear, what do you think the moment's going to be? Quadratic, second order. So let's draw the moment diagram. So what does the moment start at? What's the bending moment over here? Is this positive or negative bending moment? Negative. So we're going to start off at negative W naught L squared over 2. By the way, what's the bending moment at the free end? 0. So let's check our relationships. The change in moment is the area under the shear diagram. So what is the area under the shear diagram? What's a triangle? 1/2 base L times height WL. So that's WL squared over 2, and that's positive. So if I start at negative W naught L squared over 2, and I add positive W naught L squared over 2, I get? Excellent. Now what is the shape of the moment diagram? Well, it's equal to the shear. So let's start on the left side. What is the value of the shear here? W naught L. Positive or negative? Positive. So I should have a positive slope. In fact, if I looked at it, it would be 1 to W naught L. And it changes to what as we go along? 0. This is a 0 slope. So what you want to do is kind of connect those slopes. And there is your moment diagram. See how cool that is? So the diagram, the shear diagram will tell you the curvature of the moment diagram. So again, you can see it. Constant, linear, quadratic. You're basically integrating these. You're integrating the load to find the shear. You integrate the shear to find the moment.
Is it safe to say that whenever you have a cantilever like that and you have a linear, your moment is always going to be quadratic? Or is there
it doesn't have anything to do with the cantilever. It has to do with the load.
Well, okay. Is it safe to say, though, that you have that always?
That shape? No. It's safe to say that it will be quadratic.
Quadratic, but not that shape.
Yeah. Let's look at the second. Let's look at the second one on the sheet. This one will take a little bit more time to do. I'll go ahead and tell you what the reaction force is. It should be W naught L over 2, which is basically the area under this curve. And then the moment will be that force acting through the centroid, which is 2L over 3. So multiply that by 2L over 3, and you get W naught L squared over 3. Sorry, I'm kind of wedging that in there. I'm sure if I gave you an extra minute, you could find those, but that's not the focus right now. Okay, so starting with our moment diagram, our shear diagram, what is the value of the shear that we're going to start with? Positive or negative? Positive, and it has a value of W naught L over 2. What's the shear out here at the free end? 0. Change in shear is the area under the load curve. What is the area under our loading? It's triangular shape, so 1/2 base times height. Is that a negative load or a positive load? Negative. So if I start at positive L over 2 and subtract the change, which is negative W naught L over 2, I get 0. So that works great. Now what's the shape? Well, what is the load starting here? What's the load right there? 0. So that means we should have a 0 slope. And that slope should get larger and larger and larger all the way to a value of W naught. And is it positive or negative? It's negative. So negative W naught to 1. And then all you have to do is draw something to fit in there. So there's your shear diagram. Linear, quadratic. So what's the moment diagram going to be? What order of the curve will it be? Third, yeah, cubic. So let's start with the moment. What's the moment at the left side? Is this positive or negative bending moment? Negative. So we're going to start off at negative W naught L squared over 3. What's the moment at the free end? 0. Now is the time where you can see that this particular graphical method may give you a little bit of a challenge. Because the change in moment is the area under the shear diagram. Anybody know the area of a parabolic section off the top of their head? Actually, I do. It's 2/3 base times height. In fact, if you look in the front of your book, actually it's the back of your book, you can see, it's a little hard to see, let me zoom in for just a second. This is the one we're looking at. 2/3 base times height. Now, what makes something a parabolic, a semi-parabola, or the invert, the remaining part, a parabolic spandrel, is that you'll notice at one end of the shape, here at the spandrel and here at that, you have 0 slope. Right? So it's not a section of a parabola. It's about the axis of the parabola. And that's what we have. In our case, we actually have that. Let me zoom back out. Sorry about that. This is 0 slope. So this is a parabolic section. So that area is 2/3 base times height. So in our case, 2/3 of the base, L, times the height, WL over 2, is W naught L squared over 3. And that's positive. So that does get us back to 0. Luckily, we don't need to know the centroid of that right now, so we'll forget about that. What about the slope? The slope is equal to the shear. All right? So let's start with the slope. What is the slope right here on the left side? No. It's WL over 2, and it's positive. So we're starting off at a slope of W naught L over 2. And we're getting smaller and smaller and smaller till we hit 0. So this is, we'll connect those dots. Now, though it looks a lot like the curve we previously drew, and the shape is familiar, remember, this is a quadratic curve, and this is a cubic curve. So any questions about that?